40, still game 2. So this problem is based on still game 1, but the difference is that we have some conditions. So for Alice, Bob, and take turns, with Alice starting first, initially there's gonna be an M, and we need to understand about these areas. And there's a line of piles of stills and with different numbers. But Alice will start first, but Alice and Bob will start from the left side. As you can see from here, the player can take all the stills in the first X remaining. So this means the first X remaining. And this is calculated by this value M. So for the first turn, so this M gonna be equal to 1, and the X is how many stills Alice or Bob can take, and this X will be more than or equal to 1, less than or equal to 2 times M. So for example, if M equal to 1, so this X can only be 1 and 2. So for the first turn, Alice can decide to take a 1 still, 2, or can take 2 stills together, 2 and 7. Yeah. But after that, this M will be updated to a bigger value. So it's gonna be M with X. So if X takes 1, so next time M is gonna still equal to 1. But what if X takes 2? So for the next time, M gonna be 2. So if M equal to 2, so for the next turn, it's gonna be 1 to 2 times M. So it's gonna be 1 to 4. Yeah. So if Alice take 2 stills from the first round, so Bob can take from 1 to 4 stills. So this means all left behind. For example, this is 9, 4, and 4, so Bob can take. But Alice will not do that. Alice will only take 2. So Bob can take 1 or 2. Maybe Bob gonna choose 2 optimally, and Alice can take the other 4 and 4. So in total, it's gonna be 10. So this is gonna be the maximum stills Alice can take. And we just need to return this maximum value. So if you understand this problem like this, normally we can solve it. Yeah. So this problem is based on game theory. It means you need to understand a little about what is the game theory, and normally the game theory can be solved by dynamic programming. So we're gonna use a case with memorization to solve the problem. So we're gonna define the DFS. The DFS will start from the left side. So I'm gonna prepare a position, and it's gonna be I equal to 0. And I'm going to prepare a variable Alice. This means Alice will start first. And then I'm going to prepare a variable M. So this is so this is according to the question. From the beginning, I'm going to be 1. Now I'm going to give a pass and return DFS. It's going to be start from 0, and it's going to be true for Alice, and the M going to be 1. Now we can start the DFS. So definitely, if this I is more than or equal to n, so I'm gonna return a 0, and this n is for the length of piles. Yeah. Now we can start for Alice and Bob. So I'm gonna prepare a result, and it's gonna be minus infinity if this turn is for Alice. Else I'm gonna set infinity. Now I'm gonna check the Alice turn. If this turn is for Alice, so how many stills Alice can take? For the first turn, Alice can take 1 or 2 stills. So I'm gonna use a for loop. So for I, as I've already used I, I'm gonna use the J. So for J in range, so this is for Alice. Yeah, but how many stills Alice can take? It depended on this M. Yeah. So it's gonna start from the position I, and I'm gonna check the maximum stills Alice can check. Basically, here gonna be a little bit about mathematical calculation. So we can use I plus 2 times M. Yeah. So this is gonna be the range. So if Alice can take, for example, if I equal to 0, So if I equal to 0, so this is j in range from 0 to 2. Yeah, so this j may equal to 0 and this j may equal to 1, 0 and 1 for the first term. Yeah. So for j in range I to I plus 2 times m, and for Alice I'm gonna take the maximum of all the possible results. So it's gonna be the result with a DFS. So I'm gonna start from j plus 1 because if this j equal to I to some positions, next turn definitely it's gonna be j plus 1. And inside I'm gonna set it to false because next turn gonna be Bob, and this m gonna be updated to the maximum of the m with my current value. So what is my current value? So this value is just in between I to I plus 2 times m minus 1. So this is where the value, possible value of Jane. Yeah. So this is actually for this x. This means how many spills Alice can take for this turn for Alice. So it's gonna be I if Alice takes spills from the positions I, gonna be so it's gonna be j because j gonna be bigger minus I plus 1. So this is gonna be the how many spills Alice can take. So for example, if this is j equal to I equal to 0, so j minus I, 0 plus 1, it is 1. It means 1 spill. So if this is j equal to 1 and I is still 0, so j minus 0 plus 1, it is 2 spills. Yeah. Now, but we also need to plus how many spills Alice take. So it's going to be sum from I, from the piles from I to j plus 1. Because if j equal to I, definitely it's going to take 1 spill. So I to j plus 1. Yeah. Now, this is for Alice. We need to check what if it is for Bob. We just need to copy the same code because the idea is the same. Yeah. So from here, as Bob will give in some spill to Alice, and Bob wants to give the minimum spills as many as possible. So it's going to be the minimum of the result. And for here, we don't need to sum up the spills Bob taking because we only need to give what left behind to Alice. So for Bob, gonna take the minimum, and still these areas is gonna be the same. But only we need to check the false and change it to true because next time it's gonna be Alice, and the final result gonna be this result. So this gonna be the maximum spills Alice can take if we are following these rules. Now let me run the code to check if it works. As you can see, it works. Let me first submit it first, then analyze the time complexity, and then try to optimize the code. As you can see, it works, but it is like 1 second. It is quite slow. So that is because we use the sum, and the time complexity gonna be 10 to the power of 8. Let's analyze why. So n is 100 from here. Yeah. So for this value, this I, it's gonna be 100, and for this m, it means how many. It means how many piles of spills Alice can take or Bob can take. So this m gonna be maximum 100. So 100 times 100, and we also have a for loop, and so for this for loop, we're gonna set it to 100. So 10 to the power of 6, and here we're gonna have a sum, so it's gonna be 10 to the power of 8. Yeah. Now we want to optimize these areas for the sum because we don't need it. Normally we can solve it by using a prefix sum. As you can see, it is a sum value of an array, of a continuous array. So we can use our prefix sum. So let me define a prefix. So it's going to be a list of accumulate with the piles, and my initial value gonna be 0. Now I'm gonna change these areas. I'm gonna change the sum. As you can see, the sum is just from I to j. This is actually from I to j. So if I gonna set it to prefix the sum, definitely it's gonna be j minus I minus 1, right? But we also plus a 1 because this is we're gonna set a 0 from the beginning. So it's gonna be j plus 1 minus I. Yeah, so now let's just change it to pre j plus 1 minus pre I. But there's a problem for this. If we directly use it like before, use the sum, it is okay. Now we have this kind of a j value. This j is going to be really big. It can go out of the range of n. We need to solve this problem. So from here, we don't need to take so big value. We just need to take the minimum of this value with n because we cannot go out of the range normally. And we can just copy it from here to here. Now I think we've solved the prefix sum problem. Yeah. Now let me submit it to check if we can improve the time a little bit. Now as you can see, the time is just 0.5 seconds. I think it is much better than before. And I think that's it. And the final time complexity is 10 to the power of 6 because we reduced 10 to the power of 2 time complexity. Thank you for watching. See you next time.